This recording is a quick explanation of assignment 1, how to complete the assignment, and just going over what on the Moodle page needs to be completed, where it needs to be submitted, and when. Assignment 1 is about working through an example, running example in the textbook, namely the Ames housing example, which we've discussed in class, and which will be used many times to come in the following chapters. The idea behind this assignment is a bit of a warm-up, and it's to work through a problem that you can follow along in the text and have some idea of what to do. All the R code that you need to complete this assignment can be found in the textbook, mostly in Chapter 2 in Section 2.7. But other parts of Chapter 2 as well contain bits and pieces related to the assignment. This assignment is due on Friday, February 11th, so 2 weeks from the date which it's formally assigned, and we'll go over how to submit the assignment in a moment. So what you'll do is you'll submit in the assignment 1 Dropbox on Moodle that we'll take a look at in a few minutes, an R script or markdown file, or your output. You can save it as an HTML or some other type of file or PDF. That assembles together all the necessary code chunks and then runs them with the output. And you should, as much as possible, include comments explaining what each block of your code does. Then you'll use your output to answer the Moodle quiz assignment titled Assignment 1 that we'll also take a look at in a moment. So as mentioned, this uses the Ames housing data. You can access this data directly in R. And there's a description of the data set in section 1.4. I will note that depending on how old your R implementation is, or new, the Ames housing data set has been updated a few times. And so you might have some discrepancies with how it's described in the textbook, for instance, what the first few lines of the data are and so on. So to obtain this data in this way, we're simply using a package that's built directly into R. It's also possible to obtain the data by downloading it from various websites. And as mentioned, there are some discrepancies, and that's okay. Those shouldn't cause any kind of actual issue. Now, when you work with this, use set.seed123 so that the results are reproducible. Now, because of various randomizations and so on, and also, as mentioned, differences in the data set, results you get may not match exactly those in the textbook. They also, and so they may not match other students in the class. They should be probably pretty close. But when you answer the Moodle questions, what you'll want to do is simply refer to your own work. And I'll double check to see that things match up. So don't feel like you're necessarily wrong because something that you produce isn't exactly the same as the textbook or as one of the other students. So in Chapter 2, what's done is a k-nearest neighbors, KNN model on the Ames housing data as an illustration of the modeling process. Now, in class, we briefly discussed KNN, and it's in Chapter 8 if you want to read more about it, or if you haven't seen it in another course, such as DSci401. One thing to keep in mind is you'll want to load some of the libraries, which are listed in Section 2.1, depending on how you choose to answer the question. But we aren't going to use anything related to the library H2O or the setup. Ignore any code snippets throughout the chapter that are related to H2O. So then what you'll want to do is follow the modeling process outlined in Section 2.7. So you want to implement code to perform stratified sampling on the sale price and to split the data into testing and training sets. Then you'll want to implement code to perform a k-fold cross-validation, and then perform the indicated grid search to assess the value k. And this may take several minutes to run, depending on how much memory your computer has. Then we run code to apply a KNN model to the data. And what you'll want to do is print and plot the cross-validation results, and then use your results to answer questions on the Moodle assignment. One important point here is not simply to copy and paste all the code in Chapter 2 and run it. You don't have to, and you don't want to do this. So in some sense, part of this assignment is reading over and determining what's important and required versus what's not. So as mentioned, omit anything related to the H2O package. None of that is required. But also, you may also find that other parts of the code which are described in Chapter 2 are not necessary for the questions being asked. So let's jump over to the Moodle page. So on the Moodle page under assignments, you have the PDF for assignment 1, which we just went over, and then the video link. Then what you need to submit the assignment are the Dropbox and the Moodle quiz. So in the assignment 1 Dropbox, this is where you'll submit your work. As mentioned, it's due by Friday, February the 11th at 11:59 p.m. Then you'll open the Moodle quiz. And this quiz contains a mix of multiple choice questions, such as this one. How many features are there in the Ames housing data set? What is the response variable in the Ames housing data set? And then there are questions such as this one. Which is the resampling method being used and how many times is it applied? Then there are some questions where you type in a short answer. This problem, for instance, asks, the model form used on the assignment is k nearest neighbors. What is the value of k that produces the best model in terms of minimizing root mean square error? So the answer here is simply a number. The text box size has nothing to do with the length of the answer. It's simply just the way the Moodle questions were formatted. The next question asks, what is the minimal cross-validated root mean square error for your model? So this should be something you can obtain by looking at your R output. Then we ask, what is the minimal cross-validated mean absolute error for your model? So MAE. Does it occur the same value of k in the KNN model as for the minimal root mean square error? If not, what is the corresponding value of k here? So in some sense, what we're doing in question 6 is repeating questions 4 and 5, but for the case of mean absolute error rather than mean square error. Again, these should be very short answers. So the minimal mean absolute error will just be a number, and then similarly, the optimal value of k will just be a number. So there's not much to write here. The only major writing is on question 7, where the idea is to practice summarizing what you've done in a way that's comprehensible to a non-specialist reader. So here is the setup for question 7. You have been hired as a consultant by a realtor in Ames, Iowa to analyze this data. They ask you to write a short 1 to 2 paragraph executive summary explaining what your model has demonstrated. Write this paragraph. In particular, focus on explaining how the model is making predictions. So in other words, what's the KNN model doing? And what is the associated uncertainty, i.e. the error in the predictions, what it might represent to the realtor. So explain in a way that would be accessible to a non-specialist, such as this realtor, how your model is working and what it's telling them in terms of, for instance, what does the error represent in terms of the target variable, and so on, in a way that they might find useful. You can write this in the space provided here, or if you prefer, you can attach a file if your length exceeds the space, which it probably won't, or if you prefer to do it in another format. So that's the assignment. And then, as mentioned, there's the Dropbox for the work. If you have any questions on completing the assignment on assignment 1, please let me know. As mentioned, it's due, the quiz part and the Dropbox are due on Friday, February the 11th. That should be plenty of time to get it done, but if you have any issues completing the assignment in time, you can also let me know that as well.